Now this is a repair job. This monitor's dead, but hopefully we can fix it. I was hoping for some foam inserts, but at least I have the box. Getting there. Doesn't look like it's damaged at all. Oh, yes. All right. Well, it looks pretty good except for this discolorization here. Discoloration. I hope that's something I can scrub off. I hope it's not yellowing that someone tried to remove with sandpaper or something. Let's see. I just have to know, so I'm trying rubbing alcohol first. Yeah. Look at that. All right. This should be a good restoration if I can repair it. Okay, pro tip. When you're wiping off all this nicotine sludge with rubbing alcohol, don't forget that you touched a table saw blade just a few days ago. Oof. Ouch. Okay. Second moment of truth. We're hoping for high voltage. I hear it. This monitor may actually work. Yeah. I'm not, oh, it just went off. Could be a bad capacitor, something's causing it to go into shutdown. But the tube is obviously good. I don't see any burn in. Okay, so the way this thing is behaving, it would just turn on. It would be on, and then all of a sudden you'd hear this click, and it'd just turn off. High voltage, everything off, except the low voltage light on the switch would still be on. I don't think it's a capacitor problem. I think it's a cracked trace or something, probably around the flyback. Looking at the capacitors, they all look okay, even the ones next to the heat sinks here. You can see they're not bulged, nothing leaking. You know, those look okay. So I think we'll have to do some desoldering to get this power supply board out, and then we'll remove the shielding on the bottom. There's a shielding on the bottom of the main board, and we'll look for crack traces. And of course, before we forget, let's do this. Nice pop. And also this. Short out any big capacitors on the power supply board. These usually have a bleed resistor, but you know, just to be safe. There's a latch under here somewhere to disconnect this whole board carrier, and it slides out. Here it is. Just push it down with a screwdriver. The board will slide right up like that. Okay. Set that aside for now. I need my other hand. 1 minute. And this should just slide right out. Hopefully we got everything. Oh, we missed one. One clip left. Let's free you up. It's really hard to do this with one hand. Yeah, I know. I have a tripod somewhere. I made some room and I moved it. I don't know where I put it. There we go. Just set that aside right there. Let's take this board out. Right. Next, we'll take that shield off. Just put a little flux on there. There we go. Just get that solder to flow into this wick. I could use my desoldering suction gun, but it would just fill it up really quickly. This is working just fine. Right. I don't see anything unusual. Let's take a closer look. These all look pretty good. I hope I don't have a failing flyback. So I looked all over this board. I can't see anything obvious. All the capacitors look normal. I don't see any burnt up resistors. I don't see any cracked solder joints. So I guess we'll go through the service manual. Hopefully it's not a bad flyback. I don't know, we'll see. All right, well, the first thing I started doing was looking at all these 2-watt resistors. You know, these things will be getting hot, so they tend to fail. I guess the camera wasn't on. And so I tested the power supply, and I with not connected to the CRT, and the voltages looked okay. And then I sat this board down, and I sat it on one of these clips from the horizontal output transistor that I didn't see that was underneath the board, and it destroyed the transistor for the power supply. So it took about a week, and I got a new transistor. I just replaced that. I tested the power supply again. Power supply's alive. While I was gone, I replaced a couple capacitors. I didn't really see anything that failed, but I just replaced them anyway. They just looked a little old and dry. And then I went ahead and replaced the horizontal output transistor. Here's the original D1577. It didn't test bad, but the monitor would work for a while and then turn off. So I went ahead and replaced the horizontal output transistor along with one capacitor in there that sits on the B+ line. And I don't know, well, I powered it up briefly, and it maintained high voltage and it didn't turn off. Maybe I fixed it. So I went ahead and put the shielding back on. I started putting everything back together. We'll test it here in a minute. It's really hard to test this without putting everything back together because you have all these ground wires just kind of floating around everywhere. It's kind of dangerous. So I decided just to put the shielding back on and connect all the ground wires, and I'll put the cover back on, but not screw it down, and we'll power it up and see if we get a screen. No high voltage this time. What the hell? We just had high voltage. Weird. We'll see if we have any high voltage. No. Nope. It's not driving the flyback. I don't know. Okay, we have high voltage again for some reason. Monitor's on. All I did was connect my oscilloscope. It's weird, what's different? Got me. Monitor seems to work. So what could be causing it to turn off? I'm just gonna let it run for a while. All right, so this is interesting. This is on the collector of the horizontal output transistor. I only see 22 volts peak to peak, which it should be, that's B+, that should be like 100 and something volts. All right, more investigating. Okay, I banged on it, and it went up to over 40, it went up to 60, 70 volts now. 72, it's still climbing, and there's high voltage. And I got a picture. So I think we might have a bad connection. Let's try banging on it. No, maybe not. Brightness, something's weird here with the picture. Could be the settings in the back. It could be the screen voltage is up a little too high. Okay, I found the screen voltage. All right. So this bottom one is focus. Usually the bottom one is screen, but it's focus in this case. All right, so it's looking better. We just need to figure out why it keeps turning off. Okay, I noticed that if I flex the circuit board a little bit, last time I touched these potentiometers, this one right here feels kind of loose. That doesn't seem to do anything. Oh, there we go. So I flex the board and the video jumps. So I'm thinking we just have a bad solder joint in here somewhere. I think I'll just reflow everything around the around the flyback transformer. Safety first. Okay, here we go again. Missing one. Okay, I think I found it. This is where it pays to have a good microscope. I looked at this under a magnifier, and when I flexed this corner of the board, the high voltage would cut in and out, and I started looking at all these solder joints, and look at this one right here. Yeah. I think that's the problem. And that is connected to the base. No, actually, I think that's the collector. Yeah, that's the collector of the horizontal output transistor. So let's just fix that and clean up all this nasty flux over here, because I think we probably found it. We'll look at some more of these in here, in this area. There's a lot of expansion and contraction and some heavy components. So, oh, is that the same one? Yeah, it's the same one. Yeah, you can really, it's obvious now that once you've seen it once, but yeah, there are some other big pins around here, and you can see how they have a nice, smooth solder joint. This one might be questionable. That one also has a little bit of a ring around it. So we'll reflow those, see what happens. I've been sick for like a week, and I tried to work on this when I was at my worst, and that's when I destroyed the switching transistor and the power supply. But I'm a little better now. Maybe I can do this without breaking something. Yeah, I'm gonna have to use my other hand to get this stuff back together. Just a minute. Okay, moment of truth. Let's turn the computer on first. Computer's on, 80 column mode. Uh-oh. Strange. Okay, I found another problem, which is probably related. So there's a crack in the PCB that runs underneath this connector. And if I follow it on the other side, these boards are very thin. They're not epoxy. They're just like old resin boards. Anyway, here you can see a crack in the, very fine crack in the trace. There it is. And if I focus, if I flex the board when I ohm that out, the connection's intermittent, so I'm going to join those traces and look for any other cracks. Okay, I've removed the solder mask, and I'll just flow some solder over that. All right, I have it back together. I fixed those traces. Let's see if we get a picture. All right. So that's what it was. So all we need to do is put the shield back on, and we are in business. Here's the end result. Mission accomplished.